Good morning, everybody.
Good morning,
sir.
Morning, sir.
All right, so today we're going to take a look at decimal expansions and how do we go from a fraction to a decimal and vice versa. All right, so in our previous studies, we saw how to write a fraction. All right, remember can everybody remember what an integer is? So what is the integer set or the set of integers? Remember, it was the negative numbers like -2, -1, 0, 1, 2, and so on, right? Remember, it was positive or negative or 0, whole numbers. These were not fractions. And we define fractions to be, so it was a set of rational numbers where we said it was
P over Q.
right, and P and Q are element of the integers, and of course Q is not equal to 0 because we get a division by 0 which we don't like, right? Good. Now let us kind of make sense of this thing. So if I have 0.5, right, we know, well, we could write that as a half, right, because we know that 0.5 is like a half of 1, right, intuitively. But how do we get to 0.5, right? So we start off with 2 divided by 1. So 1 divided by 2. So this is our divisor, which is 2, and this is our dividend, which is 1, and we do 2 into 1 is how much? How much times 2 could go into 1?
2 cannot go into 1.
2 cannot go into 1, so we put a 0. And since we need to add on something, we put the point and we put a 0 here. It's like we divided this number on top by 10 and multiply this number at the bottom here by 10. But don't think about that too much. We put the point, we put a 0. So now 2 into 10 is how much?
5.
5.
Right? And this is how we get, remember what we started with, 1 over 2, or 1 divided by 2, and that is equal to 0.5. Right? So that is how we get to the 0.5. Now, there are some more complicated fractions. For example, right, so there are more complicated fractions. For example, let's try, what about 9 over 10? Sorry, 9 over 11. Right, 9 over 11. Well, let's try it. So that is 11, and it has to go into 9. Can 11 go into 9?
Yes, sir.
No, it cannot.
No, sir.
11 is larger than 9, right? So we put a 0 point. We add a 0 here. 11 into 90. Well, it's about 8. So it's 8. Yeah. 8 by 11 is 88. All right. So we subtract and we get 2. Can 11 go into 2?
No, sir.
No, sir.
No, sir.
No, it cannot, right? But the thing is, this has an infinite tail of zeros. Because if we look at the decimal points, we can put a 0 here and we didn't change anything. Right? So when we bring down the 0, can 11 go into 20? Can 11 go into 20?
Yes, sir.
Yes, sir.
Yes, it can. It can go into it 1 time. So 1 by 11 is 11. And when we subtract, we get 9. Get a 0 here. All right. Can 11 go into 90?
Yes, sir.
Yeah,
Yes,
how much time?
8.
8 times. Okay. Now 8 by 11 is how much?
88.
88.
And when we subtract, we get 2. Now, are we seeing a pattern?
Yes, sir.
Yes, sir.
we could say that 9 over 11 is actually equal to 0.818181 and so on. And we could do this infinitely many times, right? We could go on for an infinite number of times. Now, what does this mean? Does this number exist? What are these numbers called, you know? Because I could have continued, but at some point I would exhaust my life trying to figure out, well, the end of this, because it's going on forever, right? So these numbers have infinite decimal expansions, but the thing is, it has a pattern. So it can be written as a fraction. So similar to how we were doing hundreds, tens, and ones, I just want to take a little time to go through what it's tens, hundreds, thousands, and so on, right? So we had like hundreds, tens, ones, then we have tenths, right? We do that by a common T. Hundreds, common H, right? This is hundreds, as in 1 over 100, right? Thousands, and so on, right? So this thing is like 0.1. It have 0 ones and 1/10. So this could be written as 1 over 10, right? As an example. Or this one, this is 0. They check 0.2. This is 0 ones and 2/10. Right? So this could be written as 2 over 10. Now look at this one. What about 0.34? Right? 0.34 could be written as, well, 0, we have 0 ones, 3/10, and 4 hundredths. So this, it comes like it is 3/10 plus 4 hundredths, right? And when we know how to add fractions, adding fractions, we did that last term. And when you add this, you get an LCM of 100. 10 into 100 is 10. 10 by 3 is 30. Plus 4, this will give you 34 over 100. Now, we know that we can reduce these things. But this is the same as me trying to change this into a whole number. Everybody can remember how to multiply by 100? Anybody know how to multiply by 100? Yeah, we just move the decimal place 2 places to the right? So multiply by 100 is like this. So this is like 34. But since we multiply by 100, we have to undo that to get back the original number, which would mean we have to divide by 100, right? Which is the same answer. So you could go either way, right? So we see how to convert fractions into a decimal, right? Please remember to mute your mics, right, if you're not spoken. Okay, cool. All right, so now let's see how to go the other way. Look at this, right? So suppose I want to know what is the decimal expansion for, the fraction. I want to write this as a fraction, 0.91911, 9191 and so on. Right? It continues like this forever. Right? 9191, this is the pattern. Now I want to know what this value is. I want to write it as a fraction. Right? Suppose somebody asked me to do 1 over 0.9191 and so on. And suppose somebody asks me to figure out what the value for that is. I cannot divide by that number because, first of all, I do not know what that number is. It goes on forever. All right, so I want to write it as a decimal. I'm sorry, as a fraction. Well, I could start by multiplying this thing. So I could say let this equal x. Remember, we mathematicians are very creative. So you could say let this equal x, right? So that means if I multiply x by 100, if I multiply x by 100, I get 100x, right? Remember from last term. But if I multiply x by 100, it's the same as multiplying this by 100, right? Watch what would happen. 1, 2. All right, so I will get, this is equal to 91 Well, 91.919191 and so on. And so, you see where that come from?
Yes, sir.
Okay. Now, if I was to write x right underneath it, x is equal to 0.919191. Now, this is interesting because if I was to subtract it, we see like this whole infinite tail is cancelled because 9 minus 9 is 0, 1 minus 1 is 0, 9 minus 9 is 0, and it goes on like that forever. So it will actually cancel off each other, right? And I know what 100 minus x. If I was to take 100 and subtract x from it, what would happen? Sorry, well, if I have 100 of something and I subtract one of that something, how much more do I have?
99.
99. So I have 99x remaining. And 91 minus 0 is how much?
91.
So I want to know what x was. Remember, I want x as a fraction, right? So all I need to do is divide both sides by 99. This cancel, and I get that x is equal to 91 over 99. And if you want to check this in a calculator, check and see if 91 over 99 gives us the same decimal expansion. Right? I think at the end it will truncate at a 2 because of the memory in a calculator, right? It cannot go on infinitely. So are you getting 0.919191 in a calculator?
Yes, sir. Yes, sir.
Right? So the trick is to multiply by a number that so that the repeat continues. Let's check this one. Right? As the next example, 0.852852852 and so on. Right? How do I get the fraction for this? How do I get the fraction? Right? Well, we could go on the same way, but if I multiply by 100, if I say let this equal x, and I multiply by 100, right, I get 85, then 285, then 285, and so on. Was that the original pattern? No, the original pattern was 852, 852, 852, and so on, right? So I see that the pattern stops here. That's so?
Yes, sir.
Right?
Yes, sir.
So what I would want to do is multiply x by 1,000 because that will put the decimal point right here. Right? So I have that 1,000x is equal to 852 0.852852 and so on. Right? We agree with this. Right? Because all we do is move the decimal place 3 places. That's how we multiply by 1,000. Right? Now, if I was to put x here and subtract x from it, so we have 0.852852 and so on. 1,000 of something minus 1 of that thing is exactly 999 of that thing. And that is equal to, right? Well, these will cancel, and that is exactly why we want the pattern to continue rather than changing the pattern, because 8 minus 8 is 0, 5 minus 5 is 0, 2 minus 2 is 0, and so on. So this is exactly what we want to do, right? We want to cancel the tail. That is our problem in case space. All right, so 852 minus 0, that is still 852. All right, so we can solve for x, divide both sides by 999. All right, so these cancel. So we have x is equal to 852 divided by 999. And you can check that in a calculator and see if you're getting it. Let's see if we get the 852 pattern. Are we?
Yes, sir. Yes, sir.
Okay, good. Now, I asked a question earlier. I was like, if I was to divide by this number, if I was saying I want to know what 1 over 9.191 is. So 1 over 0.91 recurrent, right? 9191 and so on. What would this be? Well, just now we figured out that that was how much? That was exactly 91 over 99. Right, and remember when we divided by a fraction, we invert it. So it's like 1 divided by 91 over 99. And we just invert it. So this would be 1 multiplied by 99 over 91. And this is exactly 99 over 91. Right, so you can check in a calculator, but this one will give us a more accurate value. Why? Because it is the exact value, whereas the calculator will give you an estimated value if it was to do 1 over 0.9191. Why? Because you cannot put infinite decimals in the calculator. You can only put up to a maximum amount. Right, so I think I'll get the hang of changing from decimals to fractions.
Yes, sir.
Yes, sir.
Now, I must warn you that there exist numbers that you cannot get a fraction for, that they would not be able to write it as a fraction because it doesn't have any pattern. Right? Such numbers are pi. What's the next one you all will know? You all will know the square root of 2. Right, from when we was doing the number theory last class, well, last year. Right, there's many numbers that you cannot write a fraction, right? It as a fraction. In fact, I could give all your little brain teaser or homework. You cannot write the square root of any prime number as a fraction. Right, it is impossible. Right, so if you want to find out more about that, or let's get search it. Right, look at it, look it up. So I want you all to change these for me to fractions, right? So this part will be edited out. Right, so I have these 4 questions here to try. Enjoy. 0.923923. So what should I multiply by to get where did the pattern stop? The first pattern. Anybody?
Sir, repeat the question.
Where did the first pattern stop? Well, it stopped right here. Well,
Sir. Yes,
so I
sir.
should multiply. So I should multiply by 1,000.
1,000. Yes, sir.
1000x is equal to 923.92393 and so on. And x itself is equal to 0.923923 and so on. Okay, subtracting so that these tails cancel. So you have 999x is equal to 923. Dividing both sides by 999, we get exactly x is equal to 923 over 999. Okay, next one, we have y is equal to 0.1111. Well, this one is a simple one. So this was number one. Number two, let's put it here. Number two, y is equal to 0.1111 and so on. So the pattern stopped right here. So I can just multiply by 10. So 10y is equal to 1.1111 and so on. Y is equal to 0.1111. Subtract. Notice I'm using y here because in the question it told me that y is equal to this. Right? So that's why I'm using y. 10 minus y, it is 9y. 10y minus y is 9y. These cancel and leave you with 1 minus 0, which is 1. So y is equal to 1 over 9. By just dividing both sides by 9. Right, so these 9's here will cancel. So y is equal to 1 over 9. Number 3. Right, number 3 asks us to do 0.1213, 1213, 1213, and so on. This is 0.1213, 1213, 1213, and so on. How do I get, well, where did the pattern stop?
By the 3, sir.
By the 3, so it's right here. All right, so I need to multiply by how much?
Tens of thousands.
10,000. Yeah, very good. So we have, so this was what? This was z. Z is equal to this. So we have 10,000 z is equal to 1213.1213, and well, we're subtracting z from that, so that's equal to 0.1213, and so on. The tails will cancel, and we are left with 9,999 z is equal to 1213. Dividing both sides by 9,999 will give us our answer. We have z is equal to 1213 over 9,999. All right, so everybody understanding this so far? No questions?
Yes, sir.
All right, and the last part, w is equal to 0.59219521 and so on. So w is equal to 0.952. Is 9521 or 5921? 5921. Right, 5921. This is supposed to be 5921, 5921, and so on. Where did the pattern stop?
By the 1.
By the 1, so that's here. So what do I multiply by? What do I multiply by?
Tens of thousands again, sir.
Tens of thousands again, yeah. So that is 5921.5921, and so on. W 0.59215921 and so on. Subtracting, right? We get 9,999 W. And when we subtract, we get 5921 and the infinitives cancel. All right, so W is equal to 5,921 over 9,999. And that is our answer. So that concludes today's class. Any questions on this before we close off?
No, sir.
Okay, yeah. So make sure you like, comment, and subscribe to keep up with the online classes. And I'll see you all in the next class.